Good morning. Or are we here? Sound check. Testing. 1, 2, 3. Uh, I need to find. I need to get a new microphone. I was recording the other day. I was recording some other tutorials. The microphone, the battery died, and so I was talking to the screen for like an hour without microphone, and then the whole recording got. I need to up my game. Hi everyone. How's everybody doing? Woohoo! More light. It's really sunny and warm this morning here in Boston. Monique, Andres, BDR, how are you guys doing? Good to see you around. Are you excited? What do we got going on today? What do you guys want to do today? Testing working. All right. I wanted to have Monique. I wanted to have a lazy Saturday as well, but I don't seem to have lazy Saturdays anymore. September and October are really busy months for me because I have all my teaching at the GSD at Harvard starts in September, and I have to prepare classes. And this year everything is online, so I have to adapt all the content and create more content. Anyway, the semester is just it's just really crazy. An outdoor live stream. Albert, have you guys not heard in previous streams? My neighbor, the baby that lives across, the construction workers in. Can you hear the construction? Nah, it's very soft today. Yeah, so I would be happy to do that. I would be happy to do that, but sound-wise, it would be terrible. It would be a terrible idea. What I need to do is I need to buy a better microphone system. This thing, the audio is good, but it relies on batteries, which I don't like. I just burn so many batteries. I should buy a rechargeable one, or I should buy like a desktop microphone that I can just hold here. Anyway, do any of you use microphones for streaming and these kind of things? Do you have any recommendation of a good microphone? Oh, Albert. Oh, nice. Thank you. I was gonna talk about that right now. Uh, okay, so what do we have going on today? Sujai, good morning. How are you doing? Okay, so what do we got going on today? All right, let me pull up my my cheat sheet of things that I want to cover today. All right, so today we are continuing with the introduction to, sorry, we are continuing with the Learning C# playlist. I'm actually really happy about how the playlist is coming together. For those of you who may not know it, I'm going to share my screen. For those of you who may not know it, we are currently in the middle of recording a lot of videos for this new playlist that I'm creating called Learning C# Introduction to Computer Programming for Designers, because I want to use this playlist as a foundation on let's learn C#, the basics, so that then once we know the language, now we can start learning how to use it inside other environments such as Grasshopper, Dynamo, Unity, whatever, blah, 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 any other environments that allow for C# scripting, which is a lot of the typical ones that we use in design workflows. So I want to get like the basics of vanilla C# laid down here, and then once we're done with that, then I can start other lists like, okay, now C# in Grasshopper, how does that work? C# in Unity, how does that work? And we can start doing fancy stuff in there. And and for those of you who may not know me also, I teach computational design at Harvard University at the design school, and I'm also using some of these videos as support material for the class that I teach in the fall, which is an introduction to computational design class, where I cover these topics and many other topics that relate more to geometry, etc., etc. And you didn't know, we open sourced all the lectures from last year's course, and I'm still trying to figure out what open sourcing these lectures and what we're doing in the class, what it means this year, because everything is fully online. So I'm not sure. I still don't have a clear idea of how that's going to work, because I have lectures that I'm pre-recording, but we also have sessions. It's weird. So I don't know how we're going to do that. But anyway, what I was meant to say is, like, we are currently writing, recording tutorials, small video tutorials for this series here. And so far, we have learned already the basics of how to start a C# project, a console application. We have learned the basics of using variables, arithmetics, doing conditional statements, and doing repetition with for loops, etc. And I'm actually quite happy about the exercises that we're doing. So, like, taking a break about learning a new concept and then, like, spending like a bit more time in just doing practical examples. So I think I want to keep doing that. I want to, like, insert longer examples in the middle of the playlist for those who want to just practice what we have learned. So I think that's a really good model, and I plan on doing that and on keeping doing that. So um, what we're going to do today is that we're going to continue. So I have a question for the chat. So we are doing this today. We're going to do a double stream. It's going to be 2 hours this morning and then 2 hours in the afternoon, starting at 2 p.m. Boston time. And it's going to be mostly learning C#. But we have been doing this for 3 weeks already. We're just learning C#. I want to ask the chat, is that okay with you? Do you like that? Do you want to just, like, get over with the whole playlist and then go back to doing, like, geometry jams, algorithms, etc.? Or would you like to do half and half? So maybe if we're doing double streams, the morning stream could be more learning C# videos, and then the afternoon stream could be like an algorithmic modeling challenge, a geometry jam, like something like that. Where do you feel? Feel free to leave your comments in the chat, and then we can perhaps, like, start, like, mixing things in the coming weeks. So what we're going to do today is we're going to record more videos. I want to make a video about switch statements, so conditionals. Conditionals with a switch case statement. Where is that? That would go somewhere here, I think, in between these two. Or maybe I would just, like, push it all the way to the end. Then I want to make a video, or what is my cheat sheet? What are my notes? I want to make a video about variable scope. This is super, super important. It's a topic that I forgot, but we could definitely put it here between 6.4 and the exercises. So it's like a really, really important topic. So I want to talk about it there because it's the first time that we actually have scopes. So at this point in the playlist, we have already seen structures that have scope, and therefore we can start, we can look at that concept. And it's a very important concept when it comes to variables. After this, we have done a lot of for loops and iteration. So we did a full 1 hour exercise on just printing numerical series to the console. So that was great. I think I want to do another one. I think for loops are very important. So I want to make another one here. So that would be exercise 4, which is going to be using for loops to create ASCII art, to create character art. There was a lot of excitement about that last week, but it took us a bit longer to do this than I expected. So I want to take some time today to just indulge in doing, like, nice, cool ASCII art, and then maybe we can start a challenge on the Discord for those of you who may want to try creating your own ASCII art. And then maybe that could be like a good morning topic. And then for the afternoon, I want to start looking at data structures. So I want to start looking at how can we store larger amounts of data than one variable. And we're going to learn today how to do, how to use lists and how to use arrays. And perhaps we can come up with some exercise to practice those two. We're also going to talk about the differences between lists and arrays. So that is very interesting. That is quite interesting. Yes. Um, but before we go into that, I actually want to let me check the chat. Um, so 50-50 people are on the 50-50 side. Okay, we can do that. I'm actually looking forward going back to doing geometry gems. I just love doing geometry gems, and I have a plan for a really nice one. Oh, should I offer that as a challenge, and then we can take a look at that next semester, next week. That could be interesting. So maybe I can do that by the end of the stream today. So, reminder for those of you who might be new, we have a Discord channel. Where's Discord? It's here. We have a Discord channel right here, and where we have like our offline conversations throughout the week. I see VVR who's on the chat right now. Monique is often here somewhere. I don't know. I like having conversations. I like getting to know people on the chat. So I'm going to post here a link in case you want to join the Discord. I also announce when we're going to when we're going to stream, etc., etc. We also have a calendar. All right, we have a calendar that you can subscribe, a Google Calendar, if you want to know when these streams are going to happen, and and uh, and I typically announce that I was really bad at that this week. Sorry, I apologize. I was really bad at that this week. I just didn't even schedule the streams on the channel. So I sorry. I'm sorry about that. And it looks like man just did an example in C#. Okay. Share it with us on the work sharing channel. Man, are you on the chat right now? Are you with us here? Okay. Then where am I? All right. And also, if you're new to this channel and you want to stay up to date with what we do, etc., feel free to click on subscribe, click the notification button to get notifications about new videos, new streams, etc., etc. I also want to take a little bit of time to give a shout out to my students. I have a bunch of students from my computational design class last year who have published papers about the work that we have done in two conferences this last week. So last week was the International Conference on Computational Creativity, and two of my students, Hiemin and Brian, published this paper called Printing Error, Creating Uniqueness, which was work that stemmed from the let me, where am I? That stemmed from the class that we did. So printing error. So they basically created this sort of 3D slicer of sorts that had, instead of cutting an object in like clean slices like a 3D printing slicer does, it uses some patterns to create differentiation and embed that into the print, and also add like a slightly degree of error so that you could create prints that were volumetric, or where the accumulated error of the print created these really interesting patterns and really cool geometries. I don't know. So it was an exploration on using fabrication that is not exactly precise or is not exactly measured to create indeterminacy and errors that could be interesting from a design perspective. So I wanna give them an applause and a shout out here from the channel, because I thought the paper was really cool, and they just presented it in the conference last week. I also want to give a shout out to my other students, to Sue and David, who also presented, this was last Thursday, on eCADI, the paper that they did about the work that they did in my class last year. eCADI is the European Conference for Computer-Aided Architectural Design in Europe, and the okay, so I don't know. And their paper was called Urban Emotion, and it's also part of the work that they did for my class. And it was a really cool project because what they did was they took all this data from social media, from Instagram and Twitter in particular, and then they used a neural network to analyze the emotion of the tweet. So if the tweet was happy, was not happy, etc. But they also linked that to where that tweet was located in a city, in an urban environment, and therefore they could create these maps that were taken from social media, where they could create like an urban plot of where people felt happy, where people felt sad, what kind of emotions were associated to those urban environments. And they did a case study with the city of Boston, where they plotted emotion on the urban grid. I thought it was a super interesting project as well, and I also want to give them like a huge applause here from the channel. And for those of you who might be interested in this, both the proceedings of the International Conference for Computational Creativity, this one, and the proceedings of ECADI, the European Association for Computer-Aided Architectural Design, those proceedings are available for free. You can just go to their websites and download them. And similarly, I forgot about this. And if you want to know more about those projects and other projects from, if you want to know more about those projects and other projects from last year, from the class last year, you are welcome to go to check the project catalog that we published. So we made a catalog with all the projects that students did in the class last semester, and it's also open source and it's free. You can download it from this link here. I'm going to leave the link. Maybe I can just copy the link here and on the chat. I'm going to copy the link on the chat. Wait, here. So you should be able to download it from there or from, now it's a link. Now it's a proper link, right? Yes, exactly. Alrighty, so are we ready to start? Hey, Powerstorm, good morning. Are we ready to start? Where are we? Yes, so I'm going to shut this down. I'm going to put a couple things together here. Any comments, suggestions, things you wanna do? All right. Okay. So if there are no comments, suggestions, Rodolfo, good morning. I'm going to start, and I'm going to start with because I don't have anything else to say, right? So we're gonna start with switch statements, variable scope, and ASCII art. That's going to be, I think, the agenda for this morning. Before we do that, I'm going to take a 1 minute. I need to go to the restroom. I'm going to take 1 minute. I'll be right back. Okay? Stay there. All right. Here I am again. Okay, so let's get busy. So we're going to start. We're going to do switch statements. We are going to do, what are we going to do? Then we're going to do variable scoping, and then we're going to do ASCII art. We're going to do a lot of ASCII art today. We're going to do like pyramids and boxes, and it's going to be kind of cool. I have to say that I'm really excited about a motion map in urban landscape. I wonder how it would look like in workshop. Well, you're welcome to try. Read the paper, and maybe you can see if you can apply a similar technique to the city of Warsaw. That would be great. Okay, is my sound working well? Yes. Okay, so if switch statements. So we're going to do switch statements. Switch statements, what I want to say is that I want to focus on these are particularly useful when you have to choose between a lot of options. And so, and it is similar to changing. So, for example, let's say int, how can I make an example out of this? I'm going to start with an example, and then I'm going to rewrite that so that it looks, so that it's more convenient to do with a switch statement. So let's say something, a decision that we want to make based on a number. So I don't know. So what can it be an example? So what is something that we can choose if we ask the user, give me a number, and we can have like several decisions to do based on whether if number is 0, it's 1, it's 2, it's 3, whether if those are different. Maybe we could use a char here, because I think switch statements, they take chars in the case switch. A single switch kind of based on a pattern match with a match expression. So for example, if I do char equals a, for example, switch, such letter, and then case a, and do something, and then we get a break. Oh, it works. So, okay. So we could use this as a way of, okay, so that's great. So let's do this. Letter input, and that's going to be whatever, and then I'm going to write this as a lot of if else's. So if for example, letter input equals a, then and then I'm going to say int position x equals 0, and then int position y equals 0. Can I actually do this as an example? Can I actually move something? Position x minus equals 1. For example, otherwise, if letter input equals d, position x plus equals 1. Otherwise, if letter input equals w, position y equals plus equals 1. Otherwise, if letter input, so what I'm writing here is, let's imagine we are creating a video game, and we want to use the left ASDW letters to control the motion of something on the screen, right? So we want to keep two variables, position, right? And then we want to use the AD. Actually, let me do D here, and let me do A here, and let me do position plus, position minus, and then, nope, and then console, right line, current position is, and then I'm going to write position X, position Y. And then I'm going to close parentheses, and then I can run this. Current position is -1. Huh, okay. And then this is +1. Okay. So, is this too complicated of an example? Is this too complicated of an example? Well, if I do it right after the if conditionals, it might be. If I just put it by the end of the playlist at some point, then I could actually combine it with a while loop and then just keep doing this. That could be interesting also as part of the video. I'm gonna do like the example, and I'm going to rewrite this. I will end up rewriting this so that we can just input like move, and then see where the character is. Yeah, so that's going to be a cool exercise. All right, so I think I'm ready. Should we do this? Or is this too complicated to start with? Or maybe I should just do numbers. I don't know. I'm going to start with this. I'm already here, so I'm going to start with this. Okay, so, all right. Hi. In one of my previous videos, I explained how to do simple conditional statements, so how to do simple decision making in computer programming, and I explained the if structure, the if statement, which allowed me to check for a particular condition and then make decisions whether if that condition is true or false, and it allowed me to do that by chaining, for example, a lot of if else statements, right? And that by far is the most popular conditional structure that I can apply, but it's not the only one. So I actually want to explain today another one, which is called the switch case statement, which is a structure that is also used for conditions, for specifying conditions, but it's more typically used when you actually have to check one condition against a lot of different options. And it's very popular because if we were to do this with a normal if statement, we would actually have to chain a lot of these if else's, which can be a little tedious to write, but it can also be a little tedious to read. But most importantly, it can be tedious for changing it, right? So what I have here is a very simple example. Let's imagine we were programming a small video game, and the small video game has a two-dimensional space where there's a character that we want to move up or down in the X and the Y directions. And we want to use the keys A, S, D, W to move the character around. This is a very common keyboard pattern, for example, for first-person shooters or for that kind of thing, right? So what we want to do is we want to have a program where every so often we check for input from the user, from the keyboard, right? And then based on whichever input we get from the user, then we decide to move the character to the left, to the right, up or down. With what we know so far, this program would look something like this. We have two variables here that represent where the character is, right? And then we have another input here called we have another variable called the char, which we're going to imagine that this is somehow what we would get from as input from the user. And by the end of this video, I will actually turn this into the user typing things in the console. But for the time being, we're just going to imagine that this variable represents what the user input, what the user is typing. And at this iteration of the console application, it just happened to be a W. So what we want to do is we want to check that variable, which is of the type character, a char, right? And we want to check that against all the four possible options, A, S, D, W. And depending on which letter it was, for example, if it was D, we want to move the character to the right, so X position Y. If it's A, position X is -1. If it's W, position Y goes up 1. But that depends on the coordinate system of the graphic environment you are. Sometimes Y, positive Y, is actually pointing down, so we need to double check that. And then S, if we press down, then we want to go position Y, we want to move down. All right. So what you can see is that I have written a conditional statement that checks for the four possible options within the letter input, and then changes the variable depending on that. So actually, and by the end of the program, I print to the console what is the value of the current position in position X and position Y with this string interpolation. So if I run this code, what you can see is that current position is right now 0 and 1, so positive Y, because we moved with the W, so we moved up, right? If I were to press A, which is moving left, then what I would get is that the position of the character is -1, 0. Okay? And again, by the end of this video, I will actually do this by typing in the console. Okay? Now, this structure is okay, but it could be a little tedious to write and to maintain. So there is this other structure called the switch case structure, which allows me to write this very same logic in a somehow more elegant way and with a few other optimizations and advantages. So the way that's going to work is that I'm going to first create a switch. I'm going to write the word switch, and in parentheses, I'm going to open parentheses and I'm going to open curly brackets. At this point, you should be familiar with this way of creating structures, the word that defines the structures, some kind of condition, and then the block that is defined in the structure. And inside of the switch statement, what I want to do now is, in this case, I'm not really going to write an expression. I'm not going to write what the check is going to be. What I'm going to write is the value that I want to take a look at and that I will be using for comparisons with all the possible cases that that value can take. So for example, in this case, what I'm going to do is I'm going to pass in the variable letter input, and then inside of the switch structure, I'm going to define all the possible cases that that letter input can take. So for example, in this case, I'm going to say if I were to move to the right, letter input would have the value of D. So what I do is I write the word case followed by the value of that particular case, so one of the values that I want to write a case for, and then the colon, the colon symbol. After that, inside of this, I am going to write all the code that I want to execute if the letter input had the value of D. Okay, so in this case, that's going to be moving the position of the character 1 unit in the X direction. And after I have finished writing all that code, then what I would do is I would write the word break, the keyword break, to signify that this case, all the code that needs to run for this particular case stops here. Okay? This is very confusing because you could have said, oh, maybe we should just like wrap this code inside of curly brackets, you know, and that's how the case could be defined. It could have been, but it's actually not the case for the reasons that I will explain in a minute, right? So I'm going to get to there very soon. So keep it in mind, when you define a case, you have to write the code that you want to execute for that case, and then you have to finish that code with the word break. Because if you don't, the code will leak to the next statement, all right? To the next case statement. So now it's just as easy as writing one after the other. Okay, so now if I want to move left, then position X is going to take 1 unit less, and I'm going to stop this case. Now I'm going to type, if I want to go up, then it's going to be W, and then position Y is going to increase by 1 unit, and I'm going to break. And then if I want to move down, all right, then position Y is going to decrease by 1 unit. And I'm going to break this as well, all right? So this structure that I have written here, this switch checking this value and then writing all the possible cases with their attached code that we should run given different values of letter input, is very, very similar to the structure that I had before here with all these nested if-else statements. Okay, so now I did A, so I'm moving to the left, and if I were to change this to, for example, W, then I would move up. Okay? All right, you may argue at this point, well, I mean, it's okay, it makes sense, this that you had before is the same as this, but honestly, I don't really see how much savings I have gotten in terms of writing code. It feels like it's almost like even more lines of code, right? And from a clarity point of view, maybe I could see, maybe this is a little easier to read, but we could also argue against that, you know? So it is true, maybe from a lean standpoint, it's not so much more optimized, but there are certain things that switch structures are also better at doing, because like in a way they allow a tiny bit more flexibility. So let me show a case. For example, let's say that the user were to input a key that we are not accounting for. Okay, so for example, let's say that the user just mistakenly pressed the letter G. In this case, the user didn't move anywhere, all right? But the user, but we may actually give the user some feedback about like, hey, I don't really know what to do with this key that you just told me, right? So so can you please press again? And if I were to do that, then I think if you were using an if structure, I would basically have to keep adding here else if, and account for all possible letters that are on the keyboard. And I don't want to do that, right? Similarly here, I would have to say case G and then console right line, like I don't know what to do with key letter input, all right? And break, right? So in this case, now I'm printing, something is broken. Oh yes, I'm missing a semicolon. So in this case, now I'm printing that message to the console. I don't know what to do with letter G. So current position is 0, 0. But again, I don't want to have to copy paste this for every single key that is in my keyword. So one thing that is quite interesting is that switch statements have a very special case that is called the default case, all right? The default case is basically a catch-all. It's like the trailing, like the last else in a conditional statement. It's basically if none of the above, if you didn't find any case that matched the value of letter input, then use this one as a default. Just always use that one if you didn't find anything before. So I don't know what to do with letter G, but now also this works for letter, for example, J or K. Now this works for letter K. So now I also don't know what to do with letter K. etc. Right? So this is also a little bit more, it's giving me a little bit more flexibility. But also there is this thing, what about if the user, for some reason, forgot that they had the cap locks, and instead of pressing normal lowercase letters, they were pressing uppercase letters. If that was the case, then this program would actually not work, because the character lowercase a is not the same as the character uppercase a. So something that I can do also is that I can link together several cases for the same code. So what I can do here is I can say, you could think, well, then the solution for that might be just duplicating this and making a case for uppercase A, right? But this is duplicating too much the code. So actually, switch statements allow you to duplicate for a particular case to add different cases that will be using the same code. So in this case, what we have here is that if letter input is lowercase a, or if it's uppercase A, then both cases will trigger this code that we have here. It's like saying if letter input equals lowercase a and or so double pipes if letter input if letter input equals uppercase a, then execute this code here. And similarly, I can do this, and then I can add like a case for uppercasing, and then I can do uppercase and etc. So now my code is a bit more resilient to uppercasing and lowercasing. All right, great. And I have to say though, I would argue that this structure is a little easier to read, to write, and to change based on, for example, what I can see here. For example, in this case of keyboard input. Switch statements are switch structures are really popular when it comes to these kind of things. For example, detecting keyboard input, detecting mouse input, or making decisions when you have like a lot of options. Like for example, if you have to make 10 different decisions based on 10 different numbers from 0 to 9, then a switch case structure is probably like a much elegant and much more a much better structure to deal with those situations. All right. Now you may actually be wondering, okay, so how can we actually turn this into something that the user uses to keep inputting letters? So let's actually rewrite that. So what I want to do is now I want to have an interactive console application where I can keep pressing keys over and over again and start moving virtually this character and then print to the console the position of where that character is. We're not going to move that in the screen. We're just going to print the coordinates of that virtual character. So what we can do is, because what we want to do is we want to create something over and over again. What we will need to do is we will need to wrap all of this inside of a while loop, because we could use a for loop, but we don't really know how many times we want to be doing this. We probably want to be doing this until the user presses a particular key, like escape key, or the user presses a key that is wrong. And in that case, we just want to exit, right? So so let's say that I'm going to write all of this. I'm going to wrap it inside of a while statement, okay? And then I'm going to say here, I'm going to take all of this and I'm going to paste it inside of my while loop. All right. And I'm only going to paste this code. I want to leave the position X and the position Y outside of the while loop so that their value is permanent because of the rules of variable scoping, so that their value is permanent and they don't get reset every iteration of the while loop. I still haven't added any condition here. I'll get to that in a second. And then what I'm going to do, first of all, is I'm going to print to the console a message. Like, I'm going to print to the console a message. So write line, enter a key. Okay? I'm actually going to do write. Okay? And then I'm going to enter a key. And then I'm going to capture that value as a variable. So that's going to be called input. And then, oh, sorry. I'm messing this up. I'm going to write that here. And then I'm going to say console read key. And I'm going to store the value of that key inside of my input. Okay? Let me take a moment here to see what's going on. Oh yeah, because what I want is probably I want to read a line, right? Yes, so that's what gives me a string. Yes, because read key is going to give me console key info, and then I need to turn that into a char, and that's a little bit more complicated. Yes. Oh, it's going to suck. So console key info input, and then that would be input dot key char. Do I want to do that? Do I want to do that in the video? Do I want to get into the mess of explaining that? Because the alternative is writing a read line and then getting a string and converting that string to yeah, I don't want to get into that mess. Okay, so I'm just going to do that, I think. All right, yes, I forgot that before, in previous examples, we used read line, and which takes like a full word or like a bunch of letters one after the other, and we can store that as a string. But when it comes to read key, if we look at the signature of this function, if I hover over here, what you see is that what I get back is not a character, it's a more complex object. It's a console key info. It's an object that encapsulates more properties of that keystroke. So what I need to do, and this is a little bit more advanced, like console interaction stuff, but what I need to do is I need to change the type of the variable that I'm going to use to store that information into an object of the type of what my function is giving me, which is console key info. So I can just write here console key info, or if you want to do implicit types and you just don't want to care about typing so much, you can just do var, and then the compiler will take care of figuring out what this is and storing it in the right type here for input. It will take care of giving input the right type. Okay? I like doing things more explicit so that we know what we're working on. So I'm going to leave console key input here. And then what I want to do is I want to, for this value, to this value, I want to assign the character, the char of the letter that I just pressed. And I can do that by going to input and hitting dot, and then seeing that the IntelliSense is already suggesting that I should try to read the property key char, which is of the type character, and gives me the Unicode character that represents the letter, the keyword that was just pressed. I don't know if at this point in the video tutorials we have seen already objects with methods and properties. I hope we have. I don't know where I'm going to put this video after I record it, but if you don't, then just please go to the videos where we talk about object-oriented programming, and you will be able to understand this a little better. Okay? And then now we have the character associated to the key that the user just pressed, and then we can make decisions about how to move X, Y properties, etc., and then move the character over and over again. And then I need to put in here some condition for the code to keep executing and looping over and over again. So I'm going to write here a new variable, for example, which I'm going to call keep reading keys, and I'm going to set this to true. And I'm going to say here, while this is true. Or if I want to shortcut that, I can actually just only type while keep reading key, and then it will implicitly check if this is true or not. Then do this here. I'm going to run this code, and as I do, it's going to ask me for enter a key, and then I'm going to say A, and you can see that current position moves to the left. A, I'm going to keep pressing A, I'm moving to the left, and now I'm going to start pressing D. So you see that I'm moving to the right. You see how the X is moving to the right, and then I can press W to go up. So 8-1, 8-2, 8-3, or S to go down, 3-2-1, and now I can just go crazy with all these keys. And you see that if I press something that is not a key that the system knows, it doesn't do anything, and it tells me I don't know what to do with that key that you just pressed. I don't really like that the enter key is, I enter the key and then the message goes right after that. So what I'm going to do is to make this a little cleaner. I'm going to write right after here, before I print anything, I'm going to write an empty line so that I move to the next line. I'm going to say enter a key A, D, A, D, you see, D, 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 A, W, etc., etc. All right, so that's great. So this is working. However, this program is not clean yet because it's infinite. Basically, there's no way this program is going to stop ever executing, because this variable here will always be true. So I will need to force close the console just like I did right now, which is not a great it's not a great interface. So something that I can do is I can add another condition in my system to stop executing this while loop. So for example, what I can do is I can say either, for example, I can add a special case for a particular letter. So for example, let's say that I do Q for quit, right? Or that I do case, uppercase Q as well. And then here, I want to say, if user presses Q, then I'm going to exit my program. So I'm going to write a message, exiting program. And I'm going to run this code, and I'm going to say A is blah, 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 and I'm going to press Q, and you see exiting program, but I'm actually not exiting the program at all. Why? I'm pressing Q and it's not exiting. It's not exiting because the only thing that I'm doing when I press Q is printing to the console, but I'm actually not changing anything in my program. What I need to do is, as part of that code as well, what I need to do is to take this variable, change its value to false, so that the next iteration of the while loop, this is false, this while loop doesn't execute anymore, and then the program just exits. So what I'm going to do is I'm going to write here, keep reading key equals false. And let's see if this works now. So enter a key, A, D, W, A, blah, blah, blah. Any other letter gives me an error, etc. But if I press Q now, you see exiting program. I still print the position. And then if I press a key, boom, my program just closes. All right. So great. So you can see that we have now creating a more complex program where we can keep a global state of the value of the position of the character. We have an infinite loop that is controlled by a variable. So this variable, so long as it's true, the while loop will keep executing, and we will keep asking the user to enter a key over and over again. We will parse that key into a character, and then given different values, we will either move the position and then print to the console, or if it's a special key like Q, then we will exit the program by setting the variable that is defining the condition in the while loop to set it to false, so that the while loop stops executing, and then the program hits this last line and it exits. All right, cool. So you have this. I don't know if this is your first infinitely interactive console application, but but it's an example of that. And I hope this was interesting to learn the switch case conditional structure. Thank you very much. If you like this video, subscribe, hit the bell button, etc. And see you in the next video. All right. Hey, Victor, that is a really good question. Actually, what you can do is but this is a bit more advanced, and I didn't want to get into that. You can actually just put input here, okay? And then what you can do is for each one of these cases, just go to the console key info object and see if this is equal to there is a property here that you can with an enumerator. So if input equals console key, this is the enumerator. Yes, exactly. So what you can do here is you can say, for example, if this was a conditional statement, you could say if input equals and then you access the console key enumerator. We haven't seen that. That's probably a good thing for another video. Let me write here that we should record a video for enums. For example, input equals console key dot, and then you have a lot of options to choose from. Enter, escape, the F buttons, you know, like I don't even know what the D buttons are, but you see all the F buttons here, home button, screenshot button, like you have all these options that you can volume up, volume down, volume mute, you see? And you can also use that, so you can save yourself the idea of checking for the chart, and then here you can save yourself just say if console key, and that's going to be D, right? And so therefore you can just do this, cannot implicitly convert console key to console key info. All right, yeah, so that would be this one here. If we say that the input of the key is console key D, then you take this. Otherwise, console key dot A, etc., etc., and then you start switching. And then here, for example, we could do is console key dot esc. I think is escape? No, escape, exactly. Which it feels like a bit more of a natural one, okay? But we haven't seen enumerators, and perhaps something I want to do is when I do a video on enumerators, do an example with switch case statement. I'm writing that myself in the notes here. All right. And you can also use the arrow keys for that. So for example, where is that? You see you have console key and you have arrow. You have up arrow, down arrow, left arrow, down. So you can also do the arrows for that one. All right. Moving on. Okay, good. So this is going to be the example for the switch statements. All right. Okay. I'm not sure. I got a little bit into a messy, swampy area with this console key info, etc. I'm not sure I wanted to get there with this video, but I guess I'll just put this video by the end of the playlist at some point, so that I'll put this video at the end of the playlist when people know a little bit more of C# environment, and perhaps this is not so advanced when this happens. Maybe. All right. So that's going to be the example. All right, so we're good. What is the next thing? Variable scope. Ooh, this is super important. This is super, super important. All right, so let me create a new project. Now, let me open a new Visual Studio. No. How did this go? Was this easy? Difficult? Was it messy? It was a little messy, I have to say. I felt a little messy. Streams. Where am I going with this? Create new project. Hey Salvador, good morning. Where am I going with this? So this is going to be 27. 27 variable scope. And then I'm going to add here a read key. I'm going to add here this. I'm just trying to remember to to open the window and to lock it here in my screen, because otherwise if I do that while recording the video, it's kind of it's not cool. So I'm going to save this, and I'm going to take 1 minute because I drank a lot of coffee this morning. So I need to go to the restroom, Miguel. I'll be right back. I'll be right back. All right, Victor. We have not seen structs yet. It's not going to happen anytime soon. And by anytime soon, I mean I still need to get to the point where we can explain object-oriented programming and classes and objects, and I would like to explain that first, and then talk about the case of structs as let's say as a different alternative version of classes, and what are the properties and the differences, and when is a good time to use structs and when is a good time to use classes. But I haven't gotten there yet, so it's going to take me some time to build up to getting to object-oriented programming first, and then to get into a point where we're so familiar with it that it makes sense to introduce structs, and then to explain the differences. And actually, I think classes are way more popular in C# world, so structs are they're not so common, I think. That's more of like a C++ or a C kind of thing. But they are very popular in Rhinocommon, for example, I have to say. So I would like to explain that at some point. Okay, so variable scope. So how can I write an example of that? Okay, so if int a equals, let's say int a equals 10, int b equals 5, if greater than b, string message equals greater. Else string message not greater. And then I'm going to try to print this to the console. I'm going to try to print message. So that's not going to work, and that's what I want to explain right now. And also something that I want to say is, for example, let's say that I want to add a bunch of numbers here. And sum equals 0. Sum is going to be equal to I, and then right line sum. Whoop, you see. Should I write this? I'm going to write that as part of. I'm going to write that as part of the what I'm doing here. I'm going to write it as I explain the concept. Yes, it's a bit more interactive. All right, so variable scope. This, are you paying attention for this one? This one is, I mean, I cannot stress how important the rules of scoping for variables are. All right, so please stay tuned on this one here. All right, and this is going to come. When is this coming? This video is going to go right here. So I need to say that I just explain conditional structures and for loops, and that those define scope, and that's why we're going to talk about scope right now. All right. Yes. All right, let's do this. Okay, at this point on our evolution on learning computer programming, if you're watching this video, you have probably already learned how to do conditional statements with the if structure, and you have already learned how to do iteration, repetition with either while loops or for loops, whatever you feel more inclined, or whatever resonates better with your style of coding, right? But this is a wonderful moment to talk about a property of variables that I could not explain when I explained variables, because at that time we didn't really know structures that defined this thing that I'm going to call scope, and therefore we could not talk about the problem or the property of variable scoping related to where variables are defined. So let me talk about that, but before, and this is like a super important property of variables, but before I start, let me explain which problem may we hit if we actually don't take into consideration the scope of a variable. So for example, let's say that I had two variables, a and b, and that I wanted to compare them. And based on that comparison, I wanted to create a message that then somewhere else farther down in my code, I wanted to print to the console. Okay? So instead of printing directly to the console, what I want to is to create a message that I will store in memory, and somewhere down the line in my program, I'll print that to the console. So that program, with what we know so far, could look something like this. If a is greater than b, then what I could do is I could declare a variable called, for example, message, and say this, they're greater, a is greater than b, for example, right? Otherwise, if that was not the true, what I could say, well, then if that's not the true, then that message is going to be that the variable a is not greater, okay? And then maybe imagine that there's like a million lines of code. That's why I need this message in the middle, and I really need to print this to the console at some point farther down the road. If I do that, then you can see how if I type here message, then I'm getting an error here. And that error is telling me the name message doesn't exist in the current context. But this is very strange because it does exist here. It exists. I declared the variable here. I declared it here. And even look at this error message here. This is telling me that the variable message is assigned, but the value is never used, which is also very weird because I'm trying to use it here. So here I'm trying to read this variable. And here the variable is telling me that it's never read anywhere, which I'm trying to read here. Why is this happening? Where is this disconnection happening? Okay? So that's one situation where you may hit this problem. The other situation, I'm going to cancel this out because that code doesn't work for some reason, is, for example, with, imagine that I am in a situation where I want to add together the first 10 digits from 0 to 9. I want to know what their total sum is together, which I believe is the number 45. But let's just check if that is true. Let me write a for loop that iterates over the first 10 digits. So something like this. I declare a variable I that starts at 0 that is going to be less than 10. And then probably what I need to do is I need to create a variable that I'm going to use to initialize it to 0 and then to start adding one at a time in each iteration of the for loop, the number 1, the number 2, the number 3 to the partial result, all the way until I end up with the total. So something that I can do is I can declare a variable called sum that I initialize to 0, and then every iteration I say whatever sum was before, can you increase it by the value of I? And hopefully after 10 times the value of sum will have the aggregation of 0, 1, 2, 3, 4, etc., etc. And then after the fact I should be able to write to the console the value of sum. But I'm getting the same error again. Why doesn't sum exist here if I have declared it here and I'm actually using it? This is not giving me a problem, right? So what is the problem here? The problem that is going on here is that variables have this property called the scope. And I would like you to think of the scope as the life expectancy of a variable, or in other words, if you will, the accessibility, the visibility of that variable, where it can be used and who can use it based on where they are. But what does it mean where they are when it comes to code? Does it mean like if it's lines below, lines above, etc.? Not really. What it means in code terms is that when you're writing structures like conditional statements or like for loops, I'm not sure if you noticed, but we very often use this thing called opening and closing curly brackets. And that is not just notational flavor. That actually has a very strong meaning because whenever we open and we close curly brackets, we are defining a code block. That is the technical term for that. And a block of code not only is just a way of putting a bunch of lines together so that they execute if this is true or not, but also the code blocks define scope. And a scope is basically like an environment where variables and actions can happen. The rules of variable scopes is that when it comes to variables, and this is super important, when it comes to variables, the life expectancy of a variable or where that variable can be used depends on the scope of where it was declared. And I'm going to stress the word declared here. All right, let me say that again. A variable exists only inside of the scope that it was declared in. And if you remember from my lecture, from my video on variable creation and declaration, you may remember that declaring a variable is this part here, the one where you say, when you say this is the name of the variable and this is the type. So that's one thing. And then this other part is the assignment of a value. So this is two things together, declaration and assignment. But remember that we also explained that we can split them together. So what's happening is that because I am declaring the variable message inside of this block of code here, then whenever the computer reaches the closing curly brackets, any variable that was declared inside of this scope, it's gone. It ceases to exist. And the actual technical term for that is that it becomes garbage collected. This is really a term, right? You can Google this. I'm not lying to you. So what that means is that in this, when this was true, I did create a variable. I assigned this value, but then that variable disappeared as soon as I hit this curly bracket here. Similarly, if I run the else statement, I declare this variable, I gave it a value, but then it disappeared right away when I hit this line of code. And that is why this value, so this variable here doesn't exist, because it stopped existing after these curly brackets here. So that's why this is not visible. How can I fix that? Let me explain what is happening here before we actually get into fixing anything. Here we have a very similar situation. We have a block of code that defines a scope, all right, defined by the curly brackets. And we're executing this code 10 times. And what is happening each one of those 10 times is that I am declaring a new variable called sum. I initialize it to 0. Then I add the value of I to this variable, and then that variable disappears. And this happens 10 times. I create the variable, I add the value, and the variable disappears. I create the variable, I add a value, and then the variable disappears. 10 times over and over. I'm creating using destroying, 10 different times. And that's why, and because I'm doing this inside of the for loop, that's why it's not accessible, it doesn't exist anymore outside of the block defined by the for loop. All right? So how can we fix that? Well, the rules of scoping are so that any variable exists in the scope that it was declared and in any children and any nested scope within that larger one where it was declared. So what I can do then is I can take this variable here, and instead of declaring it inside of the block, what I can do is I can go ahead and say I'm going to declare it before the block. All right, and I'm not going to give it any value. It doesn't matter. I don't have to even initialize it. You see what's happening here? Now I'm getting an error because it's telling me I cannot declare another variable because in this scope, in the children scope, this variable already exists. So what I need to do is I need to stop trying to declare it again, and what I can do is only use it at this point. Similarly here, I'm going to use this variable, okay? And you can see that I declare a variable, and then based on the condition, I give it one value or the other. But this variable, which was declared in this scope here, the one defined by static, void, main, whatever that is, I don't think we have seen what that is at this point in the playlist, right? So, because this is the scope of this variable is visible and exists at this point of the program and all the way until we finish this function here. So that's why now this works perfectly. Similarly here, what I want to do is I want to declare the variable of sum in a scope where it becomes permanently and where it becomes permanently and where I can use it over and over again to keep adding more data to it. So what I can do is I can just move this out of the for loop. I can declare it before the for loop, and then once it's declared outside of the for loop, I can use it over and over again. I can increase its value, and then after the for loop, the variable still exists, and then I can use it here. So let's see if that works. I'm going to run this code, and then you can see that I get the greater message printed to the console. That's this one. And then for the for loop, I can now print also the value of sum, which has all the aggregations of all the values from 0 to 9. All right. How is this? Was this difficult to understand? Was it complex? The idea, again, is that where you declare a variable, in which scope you declare the variable, matters a lot. And the accessibility will always be that variables will be visible and they will exist and they will be usable inside of the scope that they were declared and any nested scope, any children scope within that larger scope. After that scope ends, so in this case here, then that variable ceases to exist, it's not available anymore. It's just garbage collected, okay? The implications of this are super, super powerful because it's up to us to decide where we declare our variables so that we have like a contained scope where we live. It's not a good practice, for example, if you have a very large program with tons of variables, you don't want to be declaring all the variables to be in the parent in the main scope. Because if you're just going to be using them for a very small operation, like a for loop, for example, then you probably don't want to declare I in the parent scope. You would just want to declare them inside of where they're going to be used them, and you want to forget that variable afterwards. You want to do that because, first of all, you don't want to pollute your global scope. You don't want to have so many variables in the main scope that things may start getting confusing, or you may actually run out of names, if that's even a possibility. But also, at the same time, it's a much safer way of coding, because if I had a global I that I was using for many different for loops, then I might run into the risk of forgetting to initialize it to 0 or whatever value I want to start the for loop with, and then start from a different value from the one that I expected and end up in some error. So that's why scoping variables, wherever they're going to be used, and then not in a greater scope, is actually a really, really good practice. And it's a very good practice to do in computer programming. That's also one of the main differences between using while loops for iteration and for loops for iteration. When you use while loops, you have to declare a variable before the while loop and then just check it inside of the while loop, which means that that variable stays in that context, in that scope, until whatever the scope ends. Whereas when you use for loops, whichever variables you declare here, they are scoped within the for loop, which means that after the for loop, there is no variable of I. I stops existing after I have finished my for loop, which is a very good practice. It's actually a really good thing to do. Okay, you don't want to mix a lot of I's and things together. That can lead to a lot of mistakes. Okay. All right, awesome. So variable scoping, keep it always in mind. Where you declare variables is important. And now you have seen how the technique of separating declaration and separating assignment may actually have some meaning and some real world use. Okay? Thank you very much. See you in the next video. All right. I am losing track of how long these videos are being. I wanted to keep them short and concise. I'm not sure I'm doing a great job at that. How's that going? Who knew about variable scope and who didn't? Also, I forgot to mention variable scope. Variable scope depends on the language you're using. Why is, if some is a global variable, needs to be assigned. In some, use of an assigned local variable. In some, why it needs to be assigned. This here. Yeah, it depends on the compiler. So it depends on Visual Studio. Certain environments require initialization, certain do not. This is not really an error, because when you declare this variable, it actually gets the value of 0 as a default. I think this is just the compiler giving you an error and trying to save you from the potential error of not giving it some value, which is not really an error. So honestly, I'm not even sure why this is being the case, but in other programming environments, you would not need to actually initialize it to a value. It's just good practice in general, but it's not, I don't think it's strictly necessary, even though Visual Studio might be complaining about that. Okay, so where are we going now? ASCII, let's do some ASCII art, all right? Where is that? That's going to be an exercise, which is going to come here. Numerical series is going to be an exercise. ASCII art. All right. And that is going to, so I'm going to create a new Visual Studio project. New project. Okay, so that's going to be here. That's going to be E4 ASCII art. And let's put that in the desktop. I'm going to console, right line. Let's create some cool ASCII art. Are you seeing my screen? Where are you? Oh, where did you go? All right. And then, okay. So, where is this coming from? This is coming from for loops, from nested for loops. We're going to be using a lot of nested for loops. Okay, for this one. All right. So what are we going to do? What do you think we could do for ASCII art? I want to do a rectangle full of, with all the characters the same. I want to do a rectangle that is only the border, and I want to be able to control the thickness of the border. So let me write that down here. For ASCII art, can you give me some ideas of what we could do for ASCII art? That's going to be a solid rectangle, a non-fill rectangle with border width. We could do a pyramid. Oh, that one is a serious one. We could do a checker pattern. What else could we do? Something that we can use. Yeah, a pyramid, exactly. It's going to be a bit more interesting. We could do a pyramid. We could do a diamond as well. It's the same idea. What else we could do? Oh, we could do like a tree-like structure, like a branching structure. A diamond, exactly, yes. We could do a diamond. What else could be cool and not very complicated at this point? Some simple shape, a circle. We could do a circle, but that's going to require some trigonometry, and can we do a circle? A fractal. That we're not there yet. We need functions and we need recursions. Yes, Victor. Fractals are a little. I think they're outside of the scope for this one. And also, because since we don't have pixels, we only have like a character grid. It's not so. We can do circles. Can I do a circle? How? If we do circle. 0, 1, and the center of the circle, and then the distance, and if the distance is less than the radius, then that pixel will be full or it will not be full. Is that complicated? Huh. Maybe we can get away with that. Maybe we can do a circle. A sine wave. A sine wave with ASCII art. I'm not feeling it. I think it might be a little confusing. We could do a hollow circle. Once we do the regular circle. Hollow circle. What else? A spiral. That's also not very straightforward for a, and it's not actually what I want to do is I want to use this. So the ASCII art patterns that I want to do, they need to be helpful to illustrate the concept of nested patterns. So something that goes too far off from that, I think it's probably much better as basically a geometry gem. As a geometry gem. A ripple effect, circles in the circle. Ooh, I like that. I wonder if that could be a coding challenge for this week. Right. Okay, so I think we have a bunch: a solid rectangle, checker pattern, pyramid, diamond, circles. All right, so let's do that. Let's start simple. Yeah. Okay. All right. Are we ready for this? Woo-hoo. Okay. So let's get to this. So we're coming from nested for loops, and we're coming from this is exercise 4. So we're also coming from numerical sequences. So I may want to, because this is probably going to be a longer video, I probably want to introduce myself and talk about the playlist. So I'm going to start with that. So let's do that. Hi, and welcome to Parametric Camp. My name is Jose Luis, and in this video, I'm going to write a bunch of examples where we're going to do very simple ASCII art, such as, for example, drawing rectangles, solid rectangles, border width rectangles, circles, pyramid, like simple geometry. But I would like to use this video to illustrate the concept of nested for loops. Because this video, if you're here, you might be coming from this video is part of a larger playlist called Learning C#, Introduction to Programming for Designers. So at this point in the playlist, we just learned a bunch of really interesting techniques, such as, for example, conditional with if statements, and we just learned for loops and nested for loops. And actually, the previous video to this one was using for loops to write numerical sequences. So in this one, I want to use ASCII art as a vehicle to practicing nested for loops, which are also like a very important technique. So what I'm going to do is I'm going to implement a series of different geometrical objects using nested for loops, and we're going to do it in an ASCII hacker way. So it's going to be cool. Grab a coffee because it's going to be a little intense if you're new to computer programming, but it's going to be super cool. And the first one that I'm going to do is going to be a very simple rectangle. I'm just going to use a character, so for example the pound sign or any other character, and I'm going to use that to replicate it in a nested for loop so that we have a full solid rectangle with as many widths and with whatever width and whatever height we want to use. Okay? So let's do that. So the first thing I'm going to do is, because I want repetition, I want to use a for loop to, for example, create a line of characters. All right. So what I'm going to do is I'm going to create a for loop where I'm going to say, I'm going to create a variable type called I, and I is going to be less than, for example, let's say that the rectangle is going to be 50 characters in width. So what I want to do is I want to say I is going to be less than 50 units, and it's going to increment in units of 1. And then each one of these iterations, I'm going to write to the console a character. So for example, the pound sign. And after we have finished doing that, I'm going to write to the console an empty line character so that we can move on to the next line. If I do that, then what we can see is that in my console that shows up on the wrong screen, we're going to get this row of characters one after the other, and then you can see how the cursor is on the next line. So the cursor is ready to keep drawing more of these. Okay? So now, if what I want to do is to draw a rectangle, which is a lot of these lines together, I have been able to use repetition to draw a lot of characters in one line. So what I would want to do is I would want to use repetition to repeat the operation of drawing all these characters in one line. So the idea is that now that I have a for loop to draw all these characters, I can wrap that inside of another for loop that is going to make the drawing line operation repeat over and over again. So very simple. So I can go back to the parent, and then I can wrap that those lines of code inside of another for loop. For this one, I'm going to use the variable name j. It's very common when you nest for loops to start with I, then go to j, and if you're nesting a third one, do k, etc., etc. So j is going to be less than, for example, 20 rows, and j is going to be equal to plus plus. And then I'm going to take all this code and I'm going to wrap it inside of the for loop. And I'm taking all the code because if I did not include the right line, see what will happen. So all the lines will be drawing one after the other because I'm not moving my cursor to the next line. So that's why what I need to do is I need to move this after the for loop so that every time I draw a line, then I go to the new line and then, oops, I click on the wrong thing. And then I have my rectangle with my 20 lines of characters. All right? How is this going? Is this cool? Now, obviously, if you know me already, you know that I don't really like hard-coded numbers very much. So these two numbers, 50 and 20, represent the width and the height of the rectangle. So why not turn those into variables, right? So for example, and we're going to say int equals int width is going to be equal to 50, and int height is going to be equal to 20. All right? And then here I'm going to replace this variable with width. I'm going to replace this with height so that I can have a bit more of fine control of the size of this rectangle. And now if I wanted to make it a little smaller, so for example 40 and I don't know, 12, then I can just change those two variables and I can adapt the size of my rectangle. All right? And you probably know where I'm going with this. By the end of this video, I will ask from the user, I will ask input, I will ask for values, and then we will draw all these geometrical sequences based on whichever size the user has inputted. But we're going to do that, we will do that by the end of this video. Okay? Right, so I have been able to draw a simple rectangle, and I'm actually going to write a message here where I'm going to say solid rectangle, and I'm also going to write another empty line character here to leave myself some room for the next operation, the next ASCII figure that I'm going to draw right now. Okay, I need to take more breaks like this one because when I talk for too long without a break, I start talking nonsense. I have noticed that. I watch my videos sometimes too, so I need to take more of these breaks, get a mental break, and then plan ahead what I'm going to say, and then yes, that. Okay, so the next thing is going to be a rectangle, but now it's going to be with a border. So I want to be able to draw a border around it. Okay. So how am I going to do that? I'm going to define a variable called border, and then I'm going to implement a condition and with that condition I'm going to check if we lie on the border and then just place one character or the other. Okay. Wonderful. So let's go to the next one. The next one we're going to do is going to be a rectangle, but instead of being solid, it's going to have a border. So border rectangle, or a non-filled rectangle. Okay. So how is that going to work? Well, first of all, I'm going to use the same width and height. So just for symmetry. So pretty much what I want to do is I'm going to copy paste all the code, and I'm going to run this, and you can see I get the same result. But now what I need to do is I need to be able to figure out first a variable that is going to define how many of these characters are part of the border, 1, 2, 3. And then I need to figure out for each one of these characters here, so for this one here, for this one here, for this one here, etc., I need to figure out if they are part of the border or if they're not. So that's actually going to be very simple with a numerical check. So let me define a variable called border width, and that's going to be equal, for example, to 3 characters, right? And then what I can do is, first of all, let me think through what is going on here. You can see that as I am moving, so this whole row in the for loop has a j value of 0. This whole row has a j value of 1. The third row has a j value of 2. So for this line here, we can see that if we check if j is less or equal than the border, then we're going to know that all these characters should be either a pound or a different sign. So I can write here, I can say if the value of j is less or equal than than border width, then what I want you to do is I want you to print a pound sign. Otherwise, if it's not, I want you to print some other sign. It could be just like a white space, but I'm going to use the dot so that we can actually see which ones are empty and which ones are not. If I run this code, you can see that, it's starting to work. So we get the first line, but I messed up. I set the value of 3, but it's actually 4 lines because I introduced the less and equal. So I'm going to remove that, and I'm going to execute again. And I'm going to, so that's going to be great. So that's working. The first line above is working. How could I do this other line here? What is the rule? Well, the rule is also very simple. J, we know that for each one of the rows, j is 0, 1, 2, 3, 4, blah, 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 whatever, all the way until the last row, in which the value of j is height minus 1, because we always have like one extra value, right? So if what I do is, if I check whether if j is less than the border, or if I check that height minus the border is also greater than j, then if any of those two conditions meet, then these symbols here should also be the pound sign. So what I can do is, if j is less than the border width, or if j is greater than height minus the border width, then the symbol should be a pound sign. Otherwise, it should be a dot. And let me run this. And I think, sorry, total mess. I forgot, I messed up. This is the and symbol. And what I meant to do is like, if it's one thing or the other. So that's why I'm using the double pipes here. And if that's true, then you can see that this is almost working, but I'm getting 1 unit less. So it should be height minus 1 minus the border. Okay? So now we have the width of the rectangle here. So 3 for j, and 3 at the beginning, and 3 at the end. Now, similarly, we know that now we have to figure out the border on the left and on the right. So we also know that as we move to the right, what changes is the value of I. So I is 0 for the first column, 1 for the second column, 2 for the third column, etc., etc. So as we move to the right, the value of I increases. So we also can very easily tell that if I is less than the width that we're trying to get, then the dollar, the symbol should be the pound sign. Otherwise, it should be empty. So another one that we can check here is, or if I is less than border width, then at that point, we should also print the pound sign. So let's see if that works. Ooh, it's working. So we got the pound sign here now. And what about this one? Well, same rule as before. If I is less than the border, or if I is greater than the width of the rectangle minus the width of the border, then we should also be printing a pound sign. So I'm going to do here, or I is greater than width minus 1 minus the border width. And I'm actually, just for the sake of visual flavor, I'm going to input this. It just makes things a little easier to read. And then, now I have a rectangle, and the rectangle has 3 characters bordered all around it. So now I can nicely change this to a white space character, and then I can start playing with this. So for example, one character width, so that's the border rectangle. Or if I want 5, for example, now it's going to be like a thick rectangle. And you can see that it's not proportional, but that's not proportional just because characters are higher than wider. So, but that's part of how the system works. So we can't really change that. So I'm going to leave this at a nice value of 2 and execute this, and we can see that now we have a border rectangle. All right, cool. So let's go and try the next one. All right. Woohoo! What is going to be the next one? The next one is going to be a checker pattern. That's also going to be super easy to do. It's going to be another nested for loop like this. So let's take a look at that. All right. Actually, let me see if we can copy. So can we actually use a full this? Can we use a full rectangle? All right. Can we use some actual nice ASCII art? Oh, this one. Can I copy this? Can I paste it here? Woohoo! Nice! All right, I like this. Okay. So should I nerd that out? ASCII table. I don't like this ASCII table. I'm looking for how to explain where this is. Images. What about this one? Now I want like the full 255. This one? Yes. Where is this coming from? Yes. Why can I not open this? Is it not working? Do I have internet? Are you there? Is anyone there? I guess this link is just not working. Boo. Let me find, what is this? No, not ASCII table 255. I like this. ASCII art. the extended table, and these are the characters that I want to take a look at. These ones here. This could be fun to play with. And pipes, exactly. Those are the ones that I want. So but this doesn't really look extended ASCII. Is this what I want? But I don't have this here. I don't have the weird. This is a different one. ASCII art. Anyway, I can probably just use this one, I guess. I mean, this one is nice, but it doesn't come with a standard one. I also want to take a look at the standard one. Lookuptables.com. What the hell is that? Oh, ASCII. Ah, so it's down here. Ah, okay. Oh, I see. Okay, so maybe we can close this. All right. Yeah, so we can probably just use that. Okay. All right. So, what do I want to do about that? Okay. All right. All right. I'm actually going to put this. I'm going to talk about this after I talk about the checker pattern. The next ASCII art that we're going to be doing is going to be a checker pattern. All right. So a checker pattern is going to be basically drawing a rectangle, and then each one of the characters, alternatively, we're going to turn them on or off. So how am I going to do that? I'm going to start off also from the similar code, from the full rectangle. I'm going to stop here and say this is going to be a checker pattern, right? And then here you can see that I am basically just drawing everything full, okay? So what I need to do is, for this checker pattern, I need to find a way to detect that I want the first element to be on, the second element to be off, the third element to be on, the fourth element to be off, etc., etc. And I'm going to do that by also taking a look again at the values of I and j, because I and j are basically telling me the location of each one of those characters in my two-dimensional grid. If you think of this, if this was a screen, like a computer screen or a cell phone screen, we could think of each one of these characters as a pixel. And we can think of I and j being the location of that pixel on the screen. So I grows in this direction, starts at 0 and ends at 49 in this case, because we have 50 elements, and j grows in this direction. It starts at 0 here and goes down in this way. So actually, from now on this video, I'm going to start referring to each one of these characters as pixels. They're not exactly true, but I want to make that analogy because it will make our life easier when we move on into thinking about computer graphics. And also, this is also one of the reasons why in most computer graphic environments, the coordinate system is not on the bottom left, it's actually on the top left corner, and x grows in this direction, and positive y grows in the bottom direction, as opposite to mathematical notation. Okay, so we're going to start thinking of I and j as the location of where my pixel is on the grid. And what I want to do is, first of all, let's start working in this direction. If we know that the location I of the pixel is, for example, odd or even, then we know that that pixel should be on. And if we know that it's even, then we know that it should be off. So for 0, for 2, for 4, I'm going to want to turn that pixel on. So how can I do that? Very simple. I can say if I modulo 2 equals 0, then the character that I want to print is going to be the pound sign. Otherwise, if it's not, then what I want to write is going to be the character, for example, a dot, so that I can see now a bit more clearly what's on and what's off. If I do that, you can see that now what I get is this like vertical stripes. So basically I am getting columns of on and columns are off. Let me just replace this with a white space, and it's going to make things a bit clearer. We're getting vertical columns that are on, vertical columns off, because at this point we're only looking at the value of I. All right, and that's why every row, no matter how high where it is in the columns, every row is getting an on and off pattern in the same direction. Now what we need to do is we need to say, well, I also want to take a look at J. And if J is odd, is 0, then you leave things like they are. But if it's 1 or 3 or 4 or 7, then you change the pattern and then you move everything to the right. You're not really moving. So what we're going to do is we need to find a numerical rule between I and J so that things move to the right. So for example, one pattern that we could use is, we know that this line here has a J of 0, right? And I, 0, 2, 4, etc., etc. But we know that the second row has a J of 1. So something that we can do is, if to every value of I here, we add the number 1, then basically the first value here, which has the first pixel that has a I0, now is going to get an I1, and therefore it's going to be odd and it's going to be off. The second one, which had an I of 0, of 1, is going to become 2 now, and then it's going to be turned on. So if we add the value of 1 here, then we're actually kind of moving everything to the right, right? Now in J2, we don't want to move anything. We want the things to be as they are. But if you think about this, if we add here the value of 2, anything that was even, what is still going to be even. Now, but if we go to the value to here, to J equals 3, if we add to all these values, if we add an even value, then we're going to change. Whatever was odd is going to become even, and whatever was even is going to become odd. So the trick here is that if we add together the value of I and the value of J, the X location and the Y location, anything that was even, if we add an even number, is going to stay even. If we add an odd number, it's going to become even. So if we, on even rows, things will stay the same, but on odd rows, then things are going to shift by 1 unit. So this is just as simple as saying, I want to calculate I plus J, and then from this result, see if the value is even. And if that's the case, then do the pound sign, otherwise do a white space. And if I run this code now, you can see that, ta-da, I get a checker pattern here. Woohoo! Yes, we got it. But this checker pattern doesn't look very sexy. There's something about the pound sign that is making it very difficult for me to understand, to see this as an actual full pixel. All right? Is there anything we could do to draw this more as a full pixel? There is actually. So if you think about the ASCII table or the characters that we have available for ourselves to draw things with, at the beginning of computation times, we had just very simple characters, numbers, letters, and some basic punctuation, parentheses, open and close, commas, dots, and some curly brackets, etc. But then when they extended the basic set of ASCII characters, they came up with a bunch of really funky characters. This was back in the times when there were no computer graphics. It was just like characters on a green screen, right? So in order to create some geometry, they came up with these fancy characters that are like simple pipes, double pipes that connect crosses in 2 directions, etc. Even these gradients, so pixels that are on and off with more density, and these characters here, which are like a full pixel, so the character space full with all solid pixels, or half a pixel, left pixel, half left right pixel, and half top left pixel. So if we find this character somehow and we print that, then we will have a full solid pixel. However, where can we find that? Well, we could find it with its ASCII number, but that is a little cumbersome to run. So on my system, on Windows, I have this thing called the character map. So you can just do search and type character map, and it's going to give you something that you can use to navigate on any typeface that you have. You can use to navigate all the characters that are available. And I have chosen Courier, and I've chosen Courier New because one of the font sets that has the most characters. And if I keep scrolling down, you can see that as I reach the end on my system, I reach these funky characters, the pipes with the angles that go up and down and have crosses and T's, etc. Single pipes, double pipes. So this is actually really, really good material to do ASCII art. And then there's this one, which is called the full block. If I double click here and I copy it, now it's on my clipboard, and then I can paste it here now and make it a full solid pixel. And if I run this, ta-da! Checker pattern! Woohoo! How cool is this, right? I could also use this for the rectangles and make it a bit more solid. Each one of the previous rectangles before. So the solid rectangle, the border, etc. So solid, border, and checker pattern. Whatever your taste is, okay? So this is pretty cool. I sometimes like keeping the pound sign. I like the hackery style of using actual characters instead of, but I think for the checker pattern, this one is cooler. So I'm going to leave the pound sign for the previous rectangles, and I'm going to leave this one for the checker pattern. All right, cool. Let's try another. Let's keep trying more stuff, right? All right. Oh. Okay. So, a pyramid. How can I do? Actually, I forget how to do pyramids. Let me just try real quick first, and then. So for a pyramid, that is going to be. Let's say that we're going to use the height. Okay. So. I'm going to copy this loop here. I'm going to say, so on J is going to be the height, and here is going to be 2 times the height plus 1, right? And I will explain why that. I may have to draw here for that one. 2 times the height plus 1. And which is going to be an even number. And then here, what we can do is we can say, we have to see where we are in I, and then based on that, we have to say if I is greater than so J is 0, so it should be, what is the row at the center? The row at the center is going to be equal to height plus 1, right? I'm thinking out loud here. I will explain what I'm doing here. Height plus 1 if I is greater than center minus J, and I is smaller than center plus J, then print print the pound sign. Otherwise, print just the dot. Okay, and let's see where this takes us. I think that would be the case, right? Oh, sorry. Let's do right instead of right line. It will make things a bit better. All right, but that pyramid is off. Why is it off? So what if we start with height here? Then we're going to... Okay. But it's not perfect. I think it would be nice to have it here. But then, is this like -1 and then is this +1? Is this what we need to do? It is. Maybe we can talk about that as part of the video as well. Okay. Or no, we can just do less or equal. Yeah, of course. I never used less or equal on. I barely use it ever. Yeah, so that's why. Okay, so I think this can work. And okay. Okay. All right, so let's do this. And I think for this I'm going to draw. How's everyone holding on? Is ASCII art blowing your mind already? All right. So, okay, let me open my sketchbook and let me switch to the other screen. I am on the other screen, right? Yes. So, let me draw a grid. I'm going to draw a grid. And this grid is going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, and 5. I'm just going to leave it there. 1, 2, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right. And then here I'm going to say this is going to be, for example, 5. No, I can do that. Yeah, but I'm going to draw here. I'm going to draw another one. I'm going to draw that one. I'm going to just move it all the way here. And I'm going to say, I'm going to do this one, this one, this one. I'm going to, okay. Okay, this one here. Alright, and I'm going to draw some coordinates. I'm going to draw some coordinates here. I'm going to say I in this direction. That's going to be 0, 1, 2, 3, and 4. And I'm going to do j in that direction. I actually write the I and the j myself the same. 6, 7, and 8. Can I delete? How can I erase? No, I wanna, yeah. Can I make this thicker? Yes. Cancel. Yeah, there you go. Alright, there you go. I'm getting better at this, huh? Alright. And then I'm going to, here, I'm going to, that this is going to be 9 objects. Okay? So, where am I? I am here. Okay. Oh, and I deleted this. Great. So I'm not getting better at this. Turns out I'm not. Okay. Oof. Now, okay, so what I'm going to do is, for the pyramid, I'm going to explain the relationships between the shape of the pyramid, and I'm going to use that to illustrate how the for loop should work. And I want to make a case about drawing this kind of sketches and diagrams because they're very helpful to think through things. So I want to start doing that at the video, and then I'm going to break down the geometry of the pyramid. Okay? And I don't think we're going to do diamonds because otherwise I'm going to be here until 4 p.m. So I'm going to leave that also as an exercise for the user, for the viewer. All right? Okay. All right. So, and what do I want for? Okay. Okay. The next drawing, the next wonderful ASCII object we're going to design here is going to be a pyramid. Okay, and for the pyramid, things are going to be a little more nuanced. We're going to have to play a little bit more with the numbers. So that's why I want to first take some time and explaining diagrammatically what we're going to do. And actually, this is also an advice that I want to offer to any viewer that is checking this video and that wants to make art with computers. Do not underestimate the value of actually spending some time drawing and like breaking down the rules of what you're doing with paper and pencil, because it will actually make things much easier once you actually start designing the code. Okay, so what I'm going to do is I'm going to draw a pyramid. Okay, the pyramid is going to look something like this. And because the pyramid has a very clear rule that it has to have these two slopes at 45 degrees, in this case, I'm not going to be able to control both the height and the width. What I'm going to do is just I'm going to take one of those defining parameters. So for example, it's going to be the height, and then based on whichever height for a pyramid I want, I will calculate the width that I need for that particular pyramid. Okay? If that's the case, then for example, for this example, what it follows is that if I have a pyramid of 5 pixels units height, and remember that we're using pixels and characters, in this case interchangeably, if I have a pyramid of 5 units high, because the pyramid has the top pixel at the center and it doesn't double, then it follows that the width of the pyramid is going to be 2 times the height, so it's going to be 10 minus 1 unit. Again, because this is at the center and the width of the pyramid is going to be even. All right, so we will know that the calculation is whatever the height of the pyramid 2 times minus 1. And it will also be useful to think of where things are in our pyramid. And remember that we were using this notation for the for loops where the coordinates of each pixel start from 0. Oh, and I made a mistake. Sorry, here. I'm sorry. This is J. Where is my... This is J here. Oops. What am I doing right now? Okay, so this is J and this is I. Sorry. So I is where we are on the row and J is where we are so which, you see the diagram, don't make me say this, it just makes it more confusing. So we have a system where each pixel, for example, this is pixel 2, 1, because we use I first, where we are on the horizontal row, and where we are, when we use J, so where we are on the column. Okay? So, let me just keep that there. Okay, so what we can see is that for us, a very important point will be the center of what this pyramid is, because that is what defines where we start checking for when we should be turning pixels on and off. And the way we're going to do this is we're going to check if we should be having a pixel on and off by saying we're going to count over I. All right, we're going to start moving to the right here in this direction, and then we're going to check the value of I. And if the value of I is equal to the value of the center, which we can calculate programmatically, it will be the value of the width, the value of 9 minus the value of the height, right? So it will be 9 minus height. If we move to the right and we say, if I is going to be equal to this value, then we will want to turn that pixel on. But if we only apply that rule, we will only be turning this pixel on, this pixel on, this pixel on. So we will basically create a column at the center of the pyramid. What we want to do is we want to also incorporate to the rule that we are moving down on the pyramid. So what we can say is, as we move to the right, if I is equal to this value minus where we are in the row, so minus 1 pixel, minus 2 pixels, minus 3 pixels, etc. If I is greater than this, if I is greater than 4 minus 3, in this case 1, if it's greater, and if it is smaller than 4 plus 3, in this case 7, if it is contained within this range, then we want to turn that on. And we're going to be using the value of I, so where we are. We're going to be comparing it to the center, and we're going to say if that is greater, if I is greater than this value minus where we are here, and if it's smaller than this value 4 plus where we are here, then that's what we will do for the rule. Was this clear? Talking about these things is sometimes so difficult, but I think you see the rule. So I'm going to relate I to the center of the pyramid, and I'm going to check that it is within the boundaries of I minus, so the center, minus the width of the pyramid at this point, which is coincidentally also the number of the row at which we are in the pyramid. All right? Sorry for that. Talking about these things is not easy sometimes. So we're going to see that the code for that is actually really clean and really straightforward. Let's take a look at how that will be implemented. All right, let's do that then. Let me save this. Before I like keeping all those diagrams. Let me remove all of this. Let me remove all of this. All right, so we're here. And then I'm going to write checker pattern, and it's going to be a pyramid. Okay, let's do this. All right, let's do this. So I have created two nested for loops with I and j starting at 0 and going up to some value that I haven't defined yet. And if we look at the diagram again, I would like to remind us that first of all, we're going to fix the height, then we're going to calculate programmatically the width that we need for that height, And then we're also going to calculate the value of the center so that it's easier for our calculations. So what we're going to do is, before we start, we know the height. Height came from the user or the original parameter. What we're going to calculate now is going to be the pyramid width is going to be equal to 2 times the height minus 1. That was what we defined, what we saw here with the diagram. Whatever this is going to be 2 times minus 1 unit. And then the center row, the center column, sorry, is going to be equal to the height of the pyramid minus 1 units, right? The position at which that is equal to the height of the minus 1. All right. So now we can very easily just fill in here. So j, remember, goes from up and down. So that's going to be has to be less than the height, and I has to be less than the width. So if I is less than pyramid width. And now here, what I can check, I have to check whether if I is contained between the range of the center minus the row minus j and contained between the center plus j. So I can say here, if I is greater than center column, if greater or equal than center column minus j, and I is less or equal than center column plus j, if that is the case, then write line a pound sign. Otherwise, just write line a dot. Is that, let's see if this works. I probably have messed something up. Let's take a look. I totally messed something up. Yes, I forgot I wrote here right line, so every character gets written to a new line as opposed to just writing them on the same line. So I'm just going to replace this, and let's see if that works. Oh my god, it works! First time! Woohoo! I love that. Woohoo! Obviously, we could also replace this pyramid, these characters with full blocks or not, but I do actually, for this one, I like keeping sorry, I would like to keep the I don't know what to say. I'm losing. I would like to keep the pound sign, and I would like to keep the dots because they actually look like the sky in some way, in some strange way. Something that we could extend. So we could extend this idea also to doing a full diamond. So we could also find some numerical rules to say what is the height, what is the center value, and then as we pass, then start working with the value of j in a different way after we have passed the center of the pyramid. Also, things that we could do is like we could find if we are exactly at the border of the pyramid and then draw like a forward slash like this. We could also find if we are exactly at this border of the pyramid and then draw a backwards slash. And we can do all those things together, including with a pyramid, with a diamond. But that, I'm going to leave that up to you, the viewer, to give it a try. And I'm going to do the last exercise, which is going to be trying to draw a circle, actually, within this ASCII art. Let me show you how that works. Alrighty. Okay, so should I do another diagram? I should probably do another diagram, right? Alright, so this is going to be a new one. Alright, and then I probably want to do something like drawing a circle, Well, that is not a terrible circle. I've done much worse in my life. Okay, and then so this pixel, this pixel, these pixels are going to be on. And this pixel is going to be on, and this pixel, and this pixel, and this pixel, and this pixel is probably going to be on as well. This one is going to be on. Okay, and this one is going to be on, and maybe these ones are going to be on, and these ones are going to be on. Wow, this looks terrible. All right. That looks so bad. And then I'm going to, let me move this here. Yes, let me move that there. And then something that I can do is I can draw, how are we holding on? Something I could just draw, find which pixel, where is the center, right? That pixel, and that is the radius, right? And then for any other pixel, and that I can probably draw. I can probably draw. I can probably draw myself. Okay. All right. All right. As I said, it's very useful very often to draw diagrams and to get a clear idea of how we can write algorithms to make these things. So I also drew the here like the shittiest, oh, sorry, I should not say that word, a really bad a really bad grid of pixels, right? And then what we want to do here is we want to say, imagine that we have a circle that is centered in this grid of pixels, all right? And the center is somewhere here, and we have a particular radius, right? We want to make a rule where we say, well, I'm going to calculate the center. I'm going to look at the center of each one of these red pixels. And if the center is inside of this circle, then I'm going to turn it on. But if it's outside, I'm going to turn it off. But then how could I do that? How could I actually calculate that? Well, I know the coordinates of each one of these points because I know I have I and I have j, so I have like x and y for each one of my pixels. So a very simple rule that I can apply is I can do some trigonometry and say, if I'm going to calculate this coordinate, I'm going to calculate the distance of this pixel to the center of the circle, and if that distance is less than the radius, then this pixel should be off. But if the distance is greater than the radius, then no, actually the other way around, sorry. If the distance is greater than the radius, then this pixel should be off. But if the distance is less than the radius, then this pixel should be on. All right, so for this one, it will be off. For this one, it's going to be on. And how can I calculate the distance? Well, I don't know if you remember, but the distance between 2 points, I have videos on my on my geometry gem. The distance between 2 points is a triangle like this. And I can do the Pythagorean theorem where I can say the distance between the 2 points is the square root of their x distance times their y distance square. All right, I have a video on that. That should be popping up somewhere, or it should be in the description. Or you go to the geometry gems, and then you can see this algorithm explained. It's just a Pythagorean theorem. Very easy. So let's take a look at that. What we're going to do is we're going to write 2 nested for loops, and for each pixel, we're going to calculate the distance to the center, and then we're going to decide if we should turn on or off that pixel. All right. let's take a look at how to write that code. Alrighty, and I think that's going to be the last sequence that I'm going to do. I need to take a break. Okay, so let's go here real quick. Let's write here a circle. A circle. So that circle is going to be equal to height, and this. Okay. Okay, so I'm going to do nothing here. All right. Okay, good. So I think we're good to start. Okay. Okay, so very simple. I have created here a circle, and sorry, I haven't created the circle yet. I have created two for loops, right? Where j is going to iterate between 0 and height, and I is going to iterate between 0 and width, okay? Because we might be in a rectangular situation. This is very common for example, for screens. And what we need to do now for each one of these pixels with their I and j coordinates, calculate the distance to the center. But what is the center? That is something that we can very easily calculate. I'm going to create a double, and I'm going to say center x is going to be equal to half the width, so width divided by 2, and then double center y is going to be equal to height divided by 2. And remember that for this one, I'm using doubles because the width and the height might be integer, but might be even, but might be odd numbers. So that's why I want to divide this. And to avoid integer division, I'm going to make sure to cast these things to doubles. Okay? Oh, alternatively, no, actually, something that I could do to make sure that this works is I could divide by 2.0, and this is also an implicit way because this is forced to be a double. This will be a real division. So now that we're here, for each one of the pixels, I can calculate the distance to the center. So I can say, for example, I'm going to create a variable called d, and this is going to be equal to math the square root of the two distances added together. But I don't have the distances yet. So let me calculate this. So double dx is going to be equal to whatever I is minus the coordinate of the center. Okay? And the sign doesn't really matter because I'm going to multiply this. I'm going to square this. So this is going to be dx times dx. And then double dy is going to be equal to where we are in j minus center I. And then this I'm going to add here dy times dy. So here I've calculated the distance from where I am in the horizontal to the center, the distance, vertical distance of where I am in the rows to the vertical center. I have calculated the distance by doing the square root of the squares of those two values, all right? And now with that distance, I need to decide whether if I turn this pixel on or off. So what I need to do is if d is smaller than the radius, but wait, what is the radius in this case? All right, where am I taking it from? Well, I could either say let me write a value here that is going to be double the radius, and I can either hard code this to a number, or I can say whatever the value, whichever value is smaller, the width and the height, I'm going to use that as the value. So, I'm going to use the value of half of that. So what I can do is I can say if height is smaller than the width, then radius should be 0.5 times the height. All right? Otherwise, if that's not true, oops, sorry, then radius should be equal to 0.5 times the width. What I'm saying here is because I can have two situations where my screen is like this, my rectangle is like this, or my rectangle is like this. I want to find which one is the smaller dimension and then fit the radius to half of that, or whether if the width is the smaller dimension and then fit the width to fit the radius to half of that. All right. Now with this value, if d is smaller than the radius, then print to the console console right line, not just right, the pound sign. Otherwise, console right, just a simple dot. Let's see if this works. I'm going to run this. Come on, come on, come on, come on. Woohoo! It actually does work. Let me crank up the value of let me make the height, for example, also 40. This is going to give me, instead of squares, going to give me rectangles that are, but you can see now how we're getting a circle that is actually, because the pixels are basically rectangles, they're not perfectly square, that's why everything is like squished out and it looks more like an ellipse rather than a circle. But you can see that it's doing like a nice smooth transition here. Also, if the height was 80 instead of 40, you would see how the circle actually adapts to that center because of the rules we just explained. You see how the circle is actually nicely being centered in the vertical, or if this was much wider than this one, for example, the rectangle is also going to fit, and the circle is going to fit exactly at the center and nicely within the rectangle here. Woohoo! All right, the last thing that we're going to do is we're going to accept some user input for the width and the height, so that it's a bit more interactive. I've done this in previous videos, taking user input and then converting it to the right type. So for example, here we can say console right line. So for example, right type a rectangle width. And actually, sorry, I actually need right line. So right, and then here I need width string is going to be equal to the input that I'm going to get from the user. So console read line. All right, and then I'm going to type another. Okay, so now I'm going to say I'm going to type in a new empty line so that I don't write right on top. I'm going to copy and paste this, write the rectangle height, and then this is going to be height of the string, and then this, after getting those, I'm going to try to cast them. So I'm going to do convert to int34, and this is going to be height string, and convert to int34, this is going to be width string, and I'm actually writing then the opposite. Sorry, so this should be height and this should be width. Okay, and with that I think I could actually, all right, so type a rectangle width, so that's going to be 50. Type a rectangle height, that's going to be what? It's going to be 25, and then boom, I get the results with that geometry. Okay, and you have seen in my previous videos also how to make sure that the input that was input here is numerical and there is not an error in the conversion. Okay, so how to check that this is not any string or like some gibberish but an actual number. I think that was back in my exercise video for the calculator, the interactive calculator, which is back in this in this playlist at some point before. Okay. All right. So let me print this again, like at the Triumph 60 and 40, and boom. Alrighty. Okay. Yoo-hoo. ASCII art. So I hope this was interesting to understand, first of all, how to do repetition and how to work with nested for loops. That's one thing. Second thing, how to look at the numerical rules of where each one of these characters is in a row and in a column, and how to use that as a way of turning these pixels on and off. And third, everything that we have just seen here is the core of how computer graphics works. We have been working with characters on a console application, but if instead of characters this was actual pixels, this would be for us a way of turning tiny pixels on a screen. It's just that the dimensions will be much larger. We will also have color as an option, but at the end of the day, the foundations of how to actually draw a circle on a computer screen with actual pixels is exactly the code and is exactly the logics that we have broken down in this exercise. Okay, if you were writing code for Photoshop or Illustrator and you wanted to represent those circles or those geometries on the computer screen, the code that you will be writing would be very similar in spirit and in logic to what we have seen today. But instead of characters on a console application, it will be actual pixels from your screen, which I think it's amazing, and I think it's a really good foundation to start understanding computer graphics, for example. So thank you very much for holding on. If you like what you saw here, please feel free to subscribe, to turn on the notification button, to stay up to date to all the videos that we post. And if you were watching this as part of the Learning C# series, I'll see you in the next video. I don't know what we're talking about next, but I think it's probably going to be interesting and you're going to like it. Thank you. See you in the next video. All right. Woohoo! That was a lot. Oh, my brain hurts. I don't know who decided to do these things on Saturdays. Oh, wait. That was me. Okay, so everyone, thank you for holding on for 2 hours and 45 minutes. I don't even know how you do this or why you do this. I'm not sure that I would do that for anybody else. I'm not sure that I would even do it for Dan Schiffman. Maybe I would do that for him, actually. But anyway, thank you for sticking around. So we saw today, this morning, what we saw was switch statements. We saw variable scope, super important. And we saw ASCII art as a vehicle to understanding computer graphics, which I think it's really interesting. What we're going to do this afternoon, so we have another stream coming up in 2 hours. Sorry, in 1.5, at 2 p.m. my time. So that's going to be in 1 hour and 15 minutes. And for that one, I'm going to be reviewing data structures in C#, and I'm going to teach you how to work with lists and how to work with arrays. So how to create variables that can hold not just one value, but a collection, an ordered collection of values. All right. Thank you very much. I'll see you, for those of you who may want to join, I'll see you this afternoon. And otherwise, stay tuned because we will start trimming and cutting and pasting and publishing these videos as part of the C# series and as part of the other videos that are on the channel. So thank you very much and see you in about an hour. Okay, bye. And I will do Q&A and social after that session, okay? Because I need to go grab lunch and I have to run an errand before this afternoon. So see you in about 1 hour. Thank you. Bye.